right. Hello, my name is Leah. I am an assistant professor at UT Austin in the Department of Mechanical Engineering. The title of my talk is Towards AI-Assisted Design That Works, which is a very hot take. I'm not saying nothing works yet, but I'm going to explain a little bit more about what I mean when I say AI-assisted design that works. I lead the HUCO lab, Human-Computer Design Lab at UT, and we're always looking for students. So if you have any students or if you're interested, please reach out to me. All right, so I thought that Sanjay did a great job kind of bringing our attention to people, and that's really what my research is about. How do humans collaborate with these AI tools that are being developed? And it's very unique in engineering design context because we're making physical products, but we're working on computational spaces with AI tools. So really my work is about how do they interact with them, how do we design better tools? So I want to paint a picture of a story, basically how I think about this problem. So there are many different applications of AI currently, as you guys are all aware of, and this is really changing the landscape of design. But really, what I mean by AI-assisted engineering design that works is there is good performance that we're continuously seeing. So these AI tools are performing great. They're starting to show that, okay, this can be used in the design process. But really, what is not being addressed is how do we use it well, right? And this is the missing piece, I believe, that is causing a lot of difficulty in implementing these AI tools in industry and in actual practice. And this is exactly the part that I like to research in my lab. So I believe that this has a very tight relationship, good performance and good use. And obviously, a lot of people can have different measures of what is good performance and what is good use. And I'll share a little bit about how I approach this problem. But usually, if a person is using the tool well, generally it is related to good performance, and we can also improve the tool as we use the tool. So the first research that I focus on is on the good use part. So I try to understand how AI tools impact the designers and their decision making. So this is really when they're working with these computational tools, what do those interactions look like? How does that impact their design decisions? But now I take that insight and try to develop AI tools that are good for people. And that's really the goal of my research, is that how do we implement this good use knowledge into the tools and have better performing AI tools for the future. So I'm going to talk first about this first research topic, which is understanding AI tools' impact on the designers and their decision making. So the first work that I did, this is my PhD dissertation work. So this is on trust and reliance on AI recommenders. So even to this day, although we talk about AI agents and other methods, the most prevalent way of interacting with AI tools is AI recommendations. So they give recommendations to us, and then we either choose to accept or reject or potentially modify the design. So I set up this very simple trust design problem, and there were two conditions to this study. I ran a human subject study with two conditions, one where it starts as a high-performing AI, and the performance drops to low-performing AI. Second condition, you switch that order. And I had two separate experiments for this. First is there is only one AI recommender, and second is when there are two AI recommenders that are giving suggestions. So some interesting results that I want to point out here is that confidence in AI is easily lost and hardly gained when we're using AI tools. And this might be a problem when we're adopting AI tools into industry. So the first plot shows that confidence in AI in the first condition, where it started out as a high-performing AI, we see that with high-performing AI, their confidence might increase. But we don't see that very much. It kind of stays the same throughout. And then once it becomes a low-performing AI, you see this steep drop. So we see that it's very easy to lose confidence in the AI. But looking at condition 2, when it started out as a low-performing AI, so the confidence dropped, and then it turned into a high-performing AI, we don't see a significant increase in their confidence. So it's very difficult to gain back the confidence that they have lost for the AI. And then here, we also looked at self-confidence, not just the confidence in the AI, but self-confidence. And we see that overall, we see dropping self-confidence in both conditions. So regardless of AI's performance, we see this dropping in their own confidence as in their ability to perform design. So this is very concerning. And we looked at 2 AI recommender situations, and the results were quite similar, but maybe a little more detrimental. So if you have 2 AI tools, we see both confidence in the AI and self-confidence dropping regardless of the conditions. So we see that there's this problem when we're using AI tools that maybe we need to consider when we're building our AI tools. How do we manage this drop in confidence levels and have these AI tools be actually useful for designers? Then I became curious. So a lot of engineering problems are multi-objective problems. So there are both quantitative goals, but also qualitative goals, and many different goals involved in the process. So I tried to understand how people go about balancing these goals when they're using generative design tools. So I looked at a very simple canopy design, quantitative goals, which was balancing the weight and shaded area of the canopy, and then qualitative goal being make it aesthetically pleasing. Some interesting results. So we do see that people tend to trust generative design tools in addressing the quantitative goals. So we see a high level of acceptance of what AI has generated in terms of the quantitative goals, and they have focused a lot of their effort on the aesthetics part. So what was nice about this is that obviously this lessened their cognitive load, and then it also increased their satisfaction in the designs that they came up with. But interestingly, they tend to overlook the best designs, and I'm going to explain a little bit what this means. So you would imagine that because generative design tools are working on the quantitative goals, they will perform better quantitatively. But we saw that in the free design task, which is when they're working on themselves, they actually performed better in balancing those quantitative goals. So we started to wonder why this is the case. And we looked at the distribution of designs that have been generated by people and with generative design tools. And we see that this blue plot is what only humans, and then yellow is generative design. And we see this more normal curve-like designs in the humans, right? So what that means is they're looking at more balanced designs mostly. But for generative design tools, a lot of times they're looking at all the different options and selecting them to suggest to people. So when they're depending on the AI, they're not thinking too much about, okay, what are the good, best balanced designs, but really choosing the ones AI is suggesting to them, and it ends up being not the most ideal designs that are well balanced. So this is a problem that we see in using generative design tools, and especially when it's in the form of giving a lot of different suggestions, we need to be careful because maybe people might not be thinking so critically about balancing those goals and selecting the right ones. And then I also thought about, okay, so there's a lot of text-to-image generative design tools, and also we're starting to talk a lot more about using text as a modality into the generative design process. And here, this was the prompt we gave them. Again, multiple goals. And then we looked at how they prompt with text. So this is some results that we saw. So focusing on the yellow bar, so that bar is multi-criteria prompts. So what that means is the criteria are feasibility, novelty, and aesthetics. And we looked at which of the prompts are addressing those goals. And multi-criteria, meaning that prompt involves multiple goals. When we see that, when they're prompting for more general design ideas, so conceptual design, they tend to have more multi-objective prompting. And then when it's more local and more detailed design, they tend to focus more on individual goals. So here we see more prompts about feasibility. So getting the feasibility right and addressing individual goals. So this is very interesting phenomenon that we see as well. All right, and then this is the last part of understanding the people. So here, this is new research that I've been doing. So in the engineering design process, our problems change, right? So there's divergence, so conceptual design, and then there's more detailed design, which is a little more converging. And depending on the problem, we might use AI tools differently. So we're looking at how problem open-endedness and generative CAD usage is related to each other. So how they accept, modify, and reject behavior, or modification. What type of modifications are they making? And then balancing the quantitative, qualitative objectives. How do they look different depending on the open-endedness of the problem? So this is a research that is ongoing in my lab. So now that we have kind of understood how people use the tools, I want to use the insights that I've gained to develop AI tools that are better for people. So my approach is looking at psychology-informed interactive AI tools. And this is generally what my idea is. The AI is not only thinking about all the quantitative goals that we talk about, but really it can consider the confidence level, cognitive load, right? Other things and interact with our designers in a more efficient manner. I'm just gonna touch quickly on different approaches I've been taking. First is modeling human confidence. So obviously, in order to communicate confidence to AI tools, we need to quantify that. So given the experiments that I ran, I've created this model of human confidence. I won't go into the detail, but we do see very accurate prediction of human confidence given an experience in the prior stage. So using this, we can incorporate this into AI tools and be able to interact or create AI tools that interact more actively, considering the designer's confidence levels. Also, quantifying and understanding form performance or form preference. So this is kind of trying to quantify some of the qualitative objectives that might be prevalent in design. So I've used 4 different form functions and then create different aesthetic groups to be able to quantify form preference. So again, integration of qualitative considerations into AI tools. And then CAD image prompting, this is another way. So I thought about text-to-image tools. A lot of times it's very good because image data sets are large and it gives us very inspiring and creative ideas, but it's not very feasible. So I have thought about basically supporting this text-to-image generation process with CAD images to create something that's more feasible as well as novel. And this is something that humans need when they're especially engineers need when they're designing something. And finally, capturing implicit need and context. This was actually one of my posters during the poster session yesterday. So one way I've been going about capturing implicit needs, so a lot of our understanding of users is based on text data at the moment in the AI tools, but maybe potentially looking into observation and how do we observe better with AI, with the help of AI. So identifying pain points with some contextual information through videos. And then also I've been thinking a little bit more about how do we capture designer need and designer intent. And that could be through their actions within the CAD platforms, how did they design over time, and also different preferences of designs that they have as they're designing. So how do we capture that information and feed it into AI tools? Okay, so I just want to leave you guys with this. This is really my big idea of we need to have both good performance and good use. And I would like to conclude my presentation. Thank you.